By the name of God, most merciful, most kind, peace be upon you all. This video is num 05 that is covering post 5 in the my website. We would like to find the L and U expressions for a given A matrix. We are still using the Doolittle's method for the 3x3 matrix. We are going to use two methods. The first method, by using the expressions that we have derived in the last video for L sub 21, L sub 31, L sub 32, and the other values for the upper matrix, which are U sub 11, U sub 12, U sub 13, and later the U sub 23, U sub 33. Second method is by using the elementary matrices to get the L and U elements for these two matrices. We'll move to the second slide. There is a task from Helm, which is helping engineers learn mathematics. Find LU decomposition for the given matrix, which is 316 minus 60 minus 16, 08 minus 17. This is a 3x3 matrix. First question asks, do matrices always have an LU decomposition? The answer is no. Sometimes it's impossible to write matrix in the form of lower matrix by the upper matrix. Why not? Because if a matrix is singular or non-invertible, then you cannot get the expression for L and U. For the third, let us check whether the given matrix is invertible or not. This is done by dividing this matrix into submatrices and get the determinant value. For instance, the submatrix A1 will contain only the first element, the first row, first column, which is 3, which is the value of A11 is plus 3, which is not 0. Then we move and create a submatrix, we call it A2, which is 2 by 2, that contains 3, 1, minus 6, and 0. We get the determinant value. The determinant value is given by multiplication of 3 by 0, and we deduct the multiplication of minus 6 by 1. 0 plus 6 equal to 6, which is not 0. Then the whole matrix, which will be 3 by 3, these are the elements. We call it A3. We get the determinant value for that matrix. We are going to find out that this determinant value is minus 6, which is not 0. Since we have all these three submatrices, determinant values are non-zeros, then we could proceed to get the LU value for the given matrix. There is another option that if you are able to reach from the A matrix to the identity matrix through row operations, if you manage to have this identity matrix, then this means that this matrix is invertible. Again, this is the A matrix, 316 minus 60 minus 16, 08 minus 17. And we start to get part of the lower matrix. First, the lower matrix, we will get the L21 and L31 by using A11 as pivot. We divide this element by this element, so we have minus 6 over 3 minus 2. This will give us the second element in the first column. We call it L sub 21 minus 2. We divide A33 over A11. This will give us the value of L31. L31 equal to A31 divided by A11, which is 0 over 3 is 0. We will take the negative values of these and we use it for the upper matrix in order to get what is called the upper matrix U1. We'll move to the next slide. Now we'll examine this L1. It is not completely a lower matrix. We have the diagonals equal to 1 based on the Dirichlet's, and this value is -2, and this we lack the value of L32, which we can get later from converting the A matrix into U sub 1 matrix. So we have L sub 1 equal to -2, L sub 31 equal to 0. We change the negative value and multiply by the row 1. For instance, in order to convert this from A to U1, we need this to be 0. So we divide this by this and change the sign, multiply by 2, 2 times row 1 plus row 2, add in the row 2. And in order to get this 0 already, we divide this 0 over 3, change the sign, multiply by R1, add to R3. For the first operation, this row 1 is kept unchanged. For the second row, we have 2 by 3, 6 minus 6 equal to 0. 2 by 1 plus 0 is 2. And 2 by 6 equal to plus 12. And add to minus 16, we have minus 4. 0 by R1, nothing, 0. Add to 0, we have 0. 0 by 1 is 0 plus 8, we have 8. And 0 by 6 is 0 minus 17. In order to get the L32, we need to create a pivot. This is a pivot. We divide this by this and change the sign in order to let this equal to 0 and to reach to the final upper matrix. We'll move to the next slide. Here it's very clear that we will use U22 as a pivot to find L32. Just only L32 is nothing but dividing this value over this value is 4. But we change the sign to -4 to multiply R2 and add to R3. So minus L32, which is -4, multiplied by 2 is 8. Minus 8 minus 4 by 2 is -8. We add to 8, we get 0. And -4 by -4 is plus 16, add, this is -1. At the end, we get this matrix as the U matrix, as we can see, for which U11, U12, U13 equals to A sub 11, A sub 12, A sub 13. Here is this one. And as you can see, if this is -2, this is +2. Here is very clear. The next step is to check whether the product of L by U will give us matrix A. Otherwise, if there is a problem and we cannot get the A matrix, it means that some of the elements are estimated incorrectly. So we have this diagonal 1, 1, 1 based on Dirichlet's methods. And we have -2, 0, 4, 1, and here 3, 1, 6, 0, 0, 2 minus 4, 0, 4. Okay. If you are using elementary matrices or identity matrix, this element is same like the first row in the identity matrix. There will be no change if you multiply this by this. These elements will be kept unchanged. This is -2. It means that we have multiplied the first row by -2 and add to the second row. -2 by 3 is -6, add to 0 is -6. -2 by 1 is -2, add to 2, 0. -2 by 6, -12, plus -4 is -16. This 0, 4, 1. 0 is a normal in the identity matrix, this is 0 and this is 0. So we have a 0. This 4 is nothing but multiplying R2 by 4 and add to R3. So 4 by 2 is 8, add to 0 is 8. And 4 by minus 4 is minus 4. Minus 16, minus 1, 7. You have the choice to use the normal way of multiplication. You multiply this by that, 1 by 3 plus 0. And multiply the row by the second column, 1 by 1 is 1. Multiply this by 6, we add here. Minus 2 by 3 is minus 6. Minus 2 by minus 1 plus 2 is 0. Minus 2 by 6 is minus 12. Minus 4, minus 16. 0 by minus 1, nothing. And this one by this 0, 0, 0, 0, 8, 8, 0, minus 16, minus 1, minus 17, same. This is the original matrix we compare. 3, 1, 6, minus 6, 0, minus 16, 0, 8, minus 17. This is matching with the original matrix. It means that our derived element values for L and U are correct. We need to check by the second option by using the elementary matrices. In order to use the elementary matrices, we will convert this A matrix into U matrix and follow and trace whatever any row operations we have used, but we will convert it into elementary matrices will be on the left side of the matrix A. We have two operations in order to eliminate these two elements. Multiplying 2 by the first row and add to the second row. We have already get these values before. 6 minus 6 is 0. 2 by 1, 2. And 2 by 6, 12 minus 16 minus 4. And this is the 0. Will create the same row here. Then the third step was dividing, using this as a pivot, divide this over this, multiply by minus 1. So multiply minus 4 R2 and add to R3. The R2 and R1 are the same, while the third row will have 0 and 0 and plus 16 minus 1. This is the three operations. We'll move to the next slide. This is two operations done in one time. So this is the identity matrix 1 0 0 0 1 0 0 0 1. In order to get the E1 that contains these two row operations, we multiply the second row, multiply 2 by the first row and add to the second row. So 2 by 1 plus 0 is 2, and 2 by 0 plus 1 is 1, and 2 by 0 is 0 plus 0 is here. Okay. And the 0, R1 plus R3, put it in R3, will not change anything in the third row. The first row is the same. So this E1 elementary matrix that has multiplication of 2 by the first row added to the second row, and multiplication of 0 to the first row added to the third row. This is the A matrix. We will put the E1 matrix at the left side of that matrix. We need to represent the third operation that will convert A to U, but we are going to put it at the left side of E1. We want minus 4 times R2 plus R3. Minus 4 times multiplied by the identity matrix will be minus 4 by 0 is 0, minus 4 by 1 is minus 4. Added to, minus 4, 0 added to 0 is 0. Minus 4 by 1 minus 4 add to 0 is minus 4. Minus 4 by 0 is 0 add to 1. This is 1. This is the E2. no change in the R1 or R2, but the only change is in the third row. We call it E2. We are going to multiply. We start from left to right. We multiply E2 by E1 to get what's called E3. 100 multiplied by 100 is same, 100. And this is the same like this second row. There is no change for the second row. But here minus 4. Minus 4 is minus 4 of R2 plus R3. So minus 4 plus 0 is minus 4. Minus 4 by 0 is 0. Adding 1, this is the 1. Okay. 100 by 316. This is shown in the next slide. But now we are saying that E3 by E1 equal to U. If we multiply by the inverse of E3 on the left side, on the right hand side we will multiply E3 minus 1. E3 minus 1, the inverse of E3, will give us the identity matrix of A, and the inverse of matrix 3 will be multiplied by the U matrix. Since I by A equal to A, then this is supposed to be L by U. So we will find out that the inverse of matrix 3 is exactly the lower matrix. We'll move to the next slide. In order to get the inverse of any matrix, we are going to use, especially if it is 3 by 3, we will use this expression. The inverse of a matrix is 1 over the determinant of matrix A, and that is called the cofactor. The cofactor C11, C12, C13, C21, C22, C23, C31, C32, C33, arranged in a column wise. But what is the value of C11? C11 is minus 1 raised to the power of the addition of row plus column multiplied of M11. M11, for instance, we remove first row and first column and get the minor M11 and get the determinant value of that. Here, this is some expressions. C21 is minus 1 raised to the power of 3 multiplied by the minor of M21, for which we erase the second row and first column. Then we come to a matrix of A12, A13, A32, A33. We are going to get the value of that matrix A12, A33 minus A13 multiplied by A32. And this is another example of C22. It will be minus 1 raised to the power of 2 plus 2 multiplied by the minor matrix M22. We get the determinant value of that minor matrix. So the title is Minors and Cofactors for Square Matrix. Okay. This is a matrix already. We call it E3. We call it C, any name. What will be the determinant value? The determinant value will be 1 multiplied by 1. And here is, this is positive, so we get determinant value of 1. The minors and cofactors we have used before for the inverse matrix of 2 by 2. We make swap and we change the sign. Why? Because we have used the expression of C11. C11 for that matrix was D is here, raised to is equal to the minor matrix, which is D, multiplied by minus 1 raised to the power of 1 plus 1 will give us positive. This is C12. This is the first row and second column is C, but it is multiplied by minus 1 raised to the power of 3. This will give us a minus. This element is C21. C21 is B, but multiplied by minus 1 raised to the power of 3. That's why it's become minus. and the last element is C22, which is element A, multiplied by minus 1 raised to the power of 2 plus 2, which is 4, positive, divided by AD minus CB. Okay. We'll proceed to estimate the C11, C12, C13, etc. C11, we remove the first row and first column. We get the minor, this is the minor basic M11, minus 1 raised to the power of 2, multiplied by the determinant of M11 minor matrix, which is 1 by plus 1. C12, we have 2, 0, minus 8, 1. Minus 1 raised to the power of 3 is minus, and this determinant value is 2, so we have minus 2. C13, we have 2, 1, minus 8, minus 4. Minus 1 raised to the power of 4 is positive, and this is minus 8 plus 8 equal to 0. C21, we have 0, 0, minus 4 and 1. The determined value is 0, while the sign is negative. C22, we have 1, 0, minus 8, 1. This is positive value, and the determined value is only 1, so we have plus 1. We'll move to the next slide. C23, we have minus 1 raised to the power of 5 will give us negative, while the determined value of M23 is 1. 3, 1 is 0, 0, 1, 0. It will give us 0. 3, 2, 3, 2. 3, 2 minus 1 is to the power of 5. This is 3 and 2. We have 1, 0, 2, 0. And the value of the determinant is 0. C33, we have 1, 0, 2, 1. Minus 1 raised to the power of 6 will give us positive value. The determinant value is 1. Now we are ready to write the inverse matrix, or it will become the inverse of lower matrix. These are the values C11, C12, C13, C sub 21, C sub 22, C sub 23, C sub 31, 0, C sub 32 equal to 0, C sub 33. This invert is the lower matrix. So we have 1, 1, 1, minus 2, and 4. This was originally our estimated lower matrix. The second method is using the augmented matrix. We can say C augmented I. This is using the expression of AX equal to B. If the X is minus 1, is the inverse of A. So we'll multiply A by A minus 1 is the identity matrix. We put the identity matrix at the right side of the matrix. And we do row operations. We multiply both sides by A minus 1, A minus 1. So at the end, if you reach to I by A minus 1, it will give you A minus 1. So after several row operations, when you start identity matrix on the I, you will end up with the matrix, inverse matrix at the right hand side. These are the operations that will give us the same L matrix. These are the two lower and upper matrices at the end. We come to the end of our videos. Thanks a lot. God bless you all. Goodbye.